Hey everyone, Blockchain Bernie here with my latest episode about the XAND-shield program. What the heck is a XAND-shield program? I'll dive into that. So you know the DevNet setup of the Xandeum solution, the scalable storage layer for Solana. And you already know, if not, look it up in my other videos, that the RPC nodes play a central role here. So if a developer develops an app that is storage enabled and uses the Xandeum storage layer, they have to send their transactions to a Xandeum enabled RPC node that runs the modified validator software, right? So it's a modified version of the Agave validator, and the modifications are all in the RPC part of that validator. So now we build that solution so that it also works with vanilla Solana validators. So we want to run it on the Solana chain and not having to create our own L1 chain, which would be kind of a fork of the Solana software, would be using the Solana code base, but it would be a chain of its own. So it would be not the Sol token that would be the base for everything, but it would be a different one. So it would be outside of that ecosystem. It would almost have been like a competition to Solana. And that's really not the place we want to be, because Solana is a great, great blockchain, right? We have been part of it for all the time, and we want to continue being part of it. So that's why if these transactions are being sent to a non-Xandeum aware RPC node, which could also be a non-Xandeum aware just normal Solana validator, right? Because each Solana validator has RPC functionality, right? It's not two distinct things. It's that one validator software that can do both the RPC functionality and the actual validating and block producing functionality. So in order to make sure that all these Xandeum transactions that utilize our storage layer are executed properly, we need to shield these Xandeum transactions from being sent directly to unmodified Solana validators, right? And we do that simply through a program, and program on Solana means smart contract, right? It's an on-chain program that's being deployed onto the chain. So our XAND-shield program, that's the one that is core to everything, right? So all of our transactions that are storage enabled, they will just be calls to the XAND-shield program. So the XAND-shield program is then being deployed to the normal Solana chain, and there it will always return an error, which just means if you send a Xandeum-enabled transaction, which always contains a call to the XAND-shield program, then this transaction will fail on Solana and will tell you, hey, this is a Xandeum-enabled transaction. You need to send it to a Xandeum RPC node in order to get it working, right? And if you send it to a non-Xandeum-enabled one, it'll just fail, right? So the XAND-shield program is being deployed on the Solana chain, and it's a trivial program. It just returns an error, right? No matter what. But then how does Xandeum work, right? Xandeum, the modified Xandeum validator in its code, in the RPC part of that code, it'll watch out for calls to the XAND-shield program, and it'll intercept these, right? So that intercept is core to how it all works. So we're intercepting these calls to the XAND-shield program and then do our stuff, right? We won't even call a program, right? We will run all that Xandeum-specific code in the RPC part of the validator, which includes orchestrating the PNodes, communicating with the PNodes, generating normal Solana transactions for these peek and poke operations that we have as part of the Xandeum chain. So the RPC part of the modified validator will execute that, will communicate with the PNodes, will store all the state of that PNode network in a few in a set of Solana accounts, which we call PNode database, PNDB. So that PNDB is a set of Solana accounts. We're building on the Solana security layer there. And that stores all that information about the PNodes. And then once that operation is done, and by the way, there's asynchronicity in there, right? So we won't execute peek and pokes at the speed of the Solana chain, right? Like 2,000 transactions per second or something. Because file systems are slower than RAM, also in normal computers, right? So we give it a little bit more time, and we build that asynchronicity in there because, of course, we don't want to hold up the Solana blockchain until, the PNodes have come back with their answers, like in a peak operation or something. So, but once those operations are done, all in the RPC node, the RPC node will generate Solana transactions that will then not run into an error, right? So that's the core of all of that. That we, after a peak operation where we read stuff out of the file system that's located on the PNodes, we will generate a Solana transaction that verifies the Merkle proof that will be sent from the PNode network, right? So that way the normal vanilla Solana validators can participate in verification, in validation of those Xandeum transactions, which is kind of a nice architecture, I feel. And the same is true with the poke operations and all these others. There's, of course, a lot of detail and a lot of code that will all be injected into the RPC part of the Agave validator software to make, the RPC nodes way more capable. And there's also a whole lot of access and caching in there so that these RPC nodes can also do search operations, which are obviously necessary to build, all these different sorts of apps. And that is our main goal, our North Star at Xandeum, sparking that Cambrian explosion of all these different sorts of on-chain apps that we're envisioning here. So, yeah, that's what the XAND-shield program is all about. So you will hear about that once we're launching that DevNet and, building the whole thing step by step. And yeah, it's quite fun for me to, keep you guys updated on all of these things here on that Blockchain Bernie channel and kind of develop the whole solution in public. And I'm doing that for a reason. I also, ask you for your feedback. So if there's any developers here, any people that have some experience in all that stuff, please give me your feedback. Ask me your questions. Ask me how does it relate to what you have done before. All these type of things so that we can learn here and build a solution that is the best possible. All right. So for now, though, thanks so much for watching, guys. Catch you later, and peace.